project started from a small curiosity, but it had the potential to provide a sustainable solution to a large-scale environmental issue. As we all know, oil spills in the sea are one of the most seriously environmental problems. They not only damage marine and coastal ecosystem, but also affect farm people life, including health, fishery, tourism, and national economy.
Although there are many oil-absorbent products, most of them have limitations such as high cost or can have long-term environmental impact. At the same time, contamination of further agricultural waste such as mango seed meal, brown banana peel, banana starch, coconut husk, rice flour, sawdust, cotton palm starch, dye fabric, and coffee.
And these materials are often burned or left to compost without being utilized, causing air pollution such as PM2.5 and greenhouse gases. And these inspire us to develop this project using agricultural waste. As oil absorbent pests, the objectives are as follows: to study method of producing oil absorbent pests on the land, and to examine the oil absorption efficiency of and bonding capacity of biomass for use in forming oil absorbent pests.
This hypothesis that if synthetic porous material can absorb oil, then natural biomass fiber with porous structure should also be effective as oil absorbent.
If the biomass had the ability to absorb oil, then oil absorbent pests made from different types of biomass will show varying level of effectiveness. The independent variable is type of biomass used in types.
The dependent variable is the amount of oil absorbent.
The control variable includes the amount of starch, the amount of seawater in oil, the amount of biomass used, and time contact sample oil, time to oil and seawater separation, drying time, thickness and dimension of oil absorbent pads. To carry the project, the research team conducted the following procedure.
The process began with preparing a mixer for 500 ml of water and 30 grams of tapioca flour, heated until clear and sticky. The group was divided into 10 equal parts of 100 grams.
Each type of biomass measured as 50 grams. When into fine and thoroughly mixed with the glue, the mixture was made into sheets with a thickness of 0.5 mm. Then baked at 80 degrees Celsius for 5 hours. After cooling, the sheets were filled in squares, measuring 6 by 6 centimeters. Before the experiment, we examined the structure of oil absorbent pests under a microscope. For testing, the sheets was placed in a container with 500 ml of seawater and 15 ml of used cooking oil for 2 minutes. The remaining oil was separated using a separatory funnel and measured.
After the experiment, we examined the structure of oil absorbent pests under a microscope. The oil absorbent pests made from coconut husk and glue showed varied oil absorption, averaging 20.36 grams. This may be due to porous and fibrous structure, which help track oil effectively.
In contrast, the makeup team pills had the lowest absorption, averaging at 14.66 grams, even less than glue. This suggests that some biomass type like coconut husk and salt have naturally high oil absorbent has property, but others like mango team pill may not be suitable.
As shown in the graph, the coconut husk has toilet blue and orange color, indicating the best performance both overall and by biomass contribution. Meanwhile, the mango skin pill had lowest performance among all type cases.
The results support hypothesis that oil absorption efficiency varies by type of biomass, depending on physical properties such as fiber structure and porosity. And this project showed great potential for turning agricultural waste into environmentally friendly absorbent materials, offering a sustainable solution to oil spill pollution. Oil efficiency of oil absorbent pad oranges lowest to highest.
The oil absorbent pad made from the coconut husk instead of glue differ in weight by 19.6 grams. This may be similar. The contrast, mango skin pill has equal without the absorption.
The result indicated is that statue is essential in forming strong, eco-friendly absorbent oil, as is by biomass materials, made effectively without reducing absorption efficiencies. Based on the study, biomass of absorbent has with a porous structure and low density, such as human have show higher oil absorption efficacy than lesser material like nicotine milk.
We start part with an empty concept that porous material can contain more liquid fibers.
Coconut has recorded the highest absorption at 12.05%, while nicotine milk had lower as its 0.25%. It is consistent with the finding of Kelly and Edward.
Before oil absorption, the coconut has activated fine, fuzzy fiber like the